All right, 8-5, day 1. We are moving into three-dimensional calculus. We're going to be finding volumes of revolution. So we're going to start with something simple. So we'll take the equation y equals x to the 1/3. We're going to restrict the domain to just 0 to 8. And then we're going to take that region and revolve around the x-axis. So, take a look at it. So y equals x to the 1/3 looks like this. And we're only looking from 0 to 8, so I'll put 8 right here. What we're going to do is 8, 4, we're in area and revolve around the x-axis. If you have any vision, you're going to see that the shape that I made it is a little short cylinder. And I'm going to do my best at drawing, but I got no judgment in my drawing because it's not going to be great. The textbook has drawings in it, but I'm going to do my best here. So as this rotates around, hopefully you see a nice little flat cylinder there. Okay, so what we're going to do is add up cylinder. So what you have to remember is the volume of a cylinder formula. I don't remember if that's E or AR. Anyway, volume of a cylinder. Volume for a cylinder is pi r squared h. So in this cylinder, we need to know, well, what's representing the radius of our cylinder and what's representing the height of our cylinder. Well, if you see this, the radius of the cylinder is given by the height of this rectangle. So this is the radius. And the height of the cylinder is its thickness right here. So how are we going to get the radius? Well, that's going to be the height of our rectangle. So the radius is top minus bottom of the rectangle. And the h, being the height, is our thickness, or what we've been calling the change in x, the dx. So from a starting value, which we'll call a, to an ending value b, from a to b of pi r squared h. So a to b pi. Our radius, when it's touching the x-axis, is given by our equation, our f of x. That has to get squared, and then our height changes to dx. Oops, sorry. So all I did was substitute the radius for the equation. Formula says you've got to square it. The height of the cylinder is given by our dx value. All right, so let's solve the problem and see that they're not too bad. So the volume will be the antiderivative from our radius is x to the 1/3. Top minus the bottom being at 0 is just giving us our f of x value, which is x to the 1/3. So I've got to put in x to the 1/3 formula says you got to square that times dx. So now it's pretty simple. I'm just going to use algebra 1 exponent rules. Pi. We multiply exponents, that'll be x to the 2/3. Oops, change that. Dx. And now it's just our antiderivative rules. Pi is a multiplier, so that's going to carry along. So it's pi. We add 1 to the exponent. And it's going to give me 5 times the reciprocal 3/5. And then we're going to be plugging in 0 and 8. Most times they leave the answers in terms of pi, but you don't have to. You can do a small decimal. Raised to the 5/3 times 3/5. I'm getting 19.2 pi minus, that'll be 0 pi. So just 19.2 pi. Minutes. Okay, let's try another one, see how much harder we can make these. Oh, well, look at that. We're going to revolve around the y-axis now and see what changes. We're going to take that same equation, x to the we're going to revolve around the y-axis. Are we doing that one? Nope, we're taking a different equation. I lied. I'm going to wait. We're just going to do in general, revolve around the y-axis. So, no equation, just a general function. I'm going to actually make it look like that last one. So now if I want to take this and revolve it around the y-axis, my rectangle has to now be positioned this way. So notice the rectangle, if I'm going around the y-axis, I am making it perpendicular to the y-axis. When I went around the x-axis, it was a tall rectangle. So at this point, our rectangles are going to be perpendicular to the axis we're going around. So when this rotates around, again, my drawing skills are going to be terrible. We're just going to get that little skinny cylinder. I don't know how to make the 3 dimensions show up here, but a little flat cylinder. Again, volume is still pi r squared h. Our radius, well actually the height of our rectangle being on the y-axis, that's a dy. So now what happens is our radius is still determined by the equation, but the equation has to be in terms of y, not x. So the volume, the general form going around the y-axis, you still need your boundaries, but your boundaries have to be y values. So these are, I'm going to put y1 and y2. Pi. Your function has to be in terms of y, not x. So it's f of y squared times dy. So all of your boundaries, your letters in your equation, and on the end all have to be in terms of the axis you are going around. So let's see how that changes things. So number 2. Find the volume of the region in quadrant 1. So we are bounded by the x and y axis in quadrant 1. In quadrant 1, bounded by y equals 1 minus x squared and rotated about the x-axis. Excuse me, y-axis. Okay, so we only need the part in quadrant 1. 1 minus x squared, if you remember, that's just an upside down parabola. Let's see, clear that out. 1 minus x squared graph. And all we want is the part in quadrant 1 here. So it's doing this. And we're going around the y-axis. So that means your rectangle is crucial. You have to draw the rectangle in to keep track of what formula you're going to be doing, because we're going to be getting more formulas here over the next few days. So we need y boundaries. Well, the origin's not a problem at 0, 0, but then I need this top y value, not the x. And what I know about this point is that x is 0. And if I put 0 in, that's going to give me 1. So I know my region is going from 0 to 1. My radius is determined has to be in terms of y. I've got to get it to x equals so that I have y's in my function. So we're just going to do a little algebra and kick it around, and then we'll do our volume formula. So pull this over here. So solving it and getting it to x equals, I'm going to be subtracting 1. Equals negative x squared. And divide by negative 1. That will give me a positive 1 and a negative y. I'm just going to go 1 minus y. And then I'm going to raise to the 1/2 power. So I've got x equals 1 minus y to the 1/2 power. All right. That means our radius is right minus left. Eventually, this is going to get a little more challenging. The right side is determined by my 1 minus y to the 1/2. The left edge is 0. And now I'm ready into my volume formula for. So the volume here is the integral from 0 to 1 of pi, my radius squared. So that's 1 minus y to 1/2. And then I have to square that. And then my h is my dy. So dy, y, y boundaries. Okay, we're going to simplify this first. 0 to 1, pi, 1/2 times 2 is going to give me a 1. So it's 1 minus y power dy. Okay, I've got options. I can distribute the pi and do each term separately, or I can do an inside-outside derivative, because I can put a -1, because the inside derivative is -1, and then just power rule. So it doesn't matter. I think I'm going to do the power rule. So the inside derivative is a -1. So that means I need a -1 here, which puts a -1 out in front. So I will have negative pi times 1 minus y. Adding 1 to that is going to give me a 2, and then times by 1/2. Going 0 to 1. So putting in the 1 first, I'm going to get 1 minus 1 is 0. 0 squared, 0, so I have 0 minus, now when I put the 0 in, I actually am going to get a value. If I put the 0 in, that's going to give me 1 squared is 1, times 1/2 is 1/2, times the negative pi, I get a -1/2 pi. So subtracting that -1/2 pi gives me 1/2 pi. Okay, one more. All right. We are going to take the region in quadrant 1 bounded by y equals 8 minus x, and we're going to rotate around the x-axis. Quadrant 1 and bounded x boundaries, so this first one's 0. I need to find this one. And what I know about this point is that the y value is 0. So if I put 0 there and solve for x, 8 minus 1/2 x, add 8 over, divide by 1/2, looks like 16. Half is 16, 8 minus 8, so this is 16. So I'm going 0 to 16. My radius is top minus bottom, which makes it just the equation. And now we're ready for volume formula. So volume, we're going 0 to 16, pi r squared, radius is the equation, r squared, and then dx, r squared h. Okay, there's no simplifying to do here. I just got to remember how to do antiderivative. So we can do a power rule, in other words, where you change this to a 3 and times a 1/3 if you have the derivative of the inside over here. If you can't get the derivative of the inside over here, then you've got to FOIL it out. But the derivative of the inside is just -1/2. Legal to just stick a -1/2 here, throw it away, put a -2 out in front. So cubed, 1/3, we're going 0 to 16. So when I put the 16 in here, I can see that's going to be the 8. That's going to give me the 0. And now when I plug the 0 in, I'm going to get something. So that'll give me 8 cubed. 8 cubed times -2/3. And if I can put down -341 1/3, or if I go to a fraction, -1024 over 3 pi, which is a positive 1024 over 3 pi. Okay, that's it. Volume, first day, easiest day.